In this video, we'll be looking at the law of cosines. The law of cosines is used when we are trying to find the missing angle or side of a triangle. The two cases where we can use it is if we know two sides of a triangle and the included side. So in other words, let's say we knew B was 8 and A was 6. So we know the two sides and the included angle. So let's say this was 62 degrees. I could use the law of cosines because that's two sides and the included angle. Or if I know all three sides of the triangle, I can use the law of cosines to find the missing angles. As a review yesterday, law of sines was when we had two sides and a non-included angle, or two angles and a side. So the formula for the law of cosines is down here. Really, these are all the same formula. What it says is a squared equals b squared plus c squared minus 2bc cosine of angle A. In other words, one of the sides squared equals the other two sides, b and c, summed and squared, minus 2 times those same sides, times the cosine of the angle corresponding to this letter. I know it sounds confusing and looks confusing, but once we do a few practice problems, I think you'll understand. So let's look here at this problem. Let's go ahead and call this x, y, and z. So the first thing you want to look at is what angle are you given? Well, you're given a 27, and it's included between the two signs. So this will be law of cosines. And if you remember, this is your formula, cosine of angle C. Now, whenever you have two sides in the included angle, you want to do the side opposite the angle you know by itself. So the side opposite 27 is x. So x squared equals 5 squared plus 9 squared. Now the order doesn't matter. I could have done 9 squared plus 5 squared. Minus 2 times 5 times 9 times the cosine of 27. Now this right here is just all numbers. There's no variables in this whole part here. So you can actually take that whole thing and type in 5 squared plus 9 squared minus 2 times 5 times 9 cosine of 27 all in your calculator. And when you do that, you get x squared equals 25.809. See, I told you it wasn't as hard as you think. You just type it in your calculator. Now, to get rid of the squared, you take the square root of both sides. So the square root of 25.809 tells you that x equals 5.08. So this side here is 5.08. Now I know all three sides and I know an angle. So the easiest way from here to go and find my other missing angles is to use the law of sines. And I'm going to start with the smaller angle. The smaller angle will be y because it's across on the smaller side. So I start sine 27 over 5.08, that's the side that corresponds, equals sine y over 5. Cross multiply, so 5 sine 27 equals 5.08 sine y. And divide by 5.08 on both sides. And just type that in your calculator now. So 5 sine 27, be sure to close your parentheses, divided by 5.08 tells me that sine y equals 0.447 when we round. Now do sine negative 1, 0.447, and you get that y equals 26.6 degrees if we round to the nearest 10. And of course, to find the third angle in any triangle, you just subtract from 180. And that tells me that this angle Z is 126.4 degrees. So the key here, when you have a missing side and the angle included, is use the law of cosines to find the other side. Then go back and use the law of sines to find your missing angle, and then subtract from 180. Okay, pause the video and try to solve for x, y, and z. All right, let's see how you did. So let's see, x is across from the included angle, so x squared equals 80 squared plus 78 squared minus 2 times 80 times 78 times the cosine of 40. Now these are all numbers, no variables, so just type it straight in your calculator. So 80 squared plus 78 squared minus 2 times 80 times 78 cosine of 40 gives me x squared equals 2923.765. To undo the square, we take the square root. So x equals 54.072. Now that we've used the law of cosines to find our missing side, let's use the law of sines to find our smaller angle, which will be z in this case. So sine 40 over 54.072 equals sine y over 78. Cross multiply. 78 sine 40 equals 54.072 sine y. Divide both sides by 54.072 to get rid of that. And we're left with 78 sine 40 divided by 54.072. Gives me 0.927 equals sine y. Inverse sine now in your calculator. Tells me that y equals 67.98. If we're rounding up with tenths, it's just going to be 68 degrees. So now subtract from 180 to find your final angle. And you get that z equals 72 degrees. And you can kind of check your work a little bit to see if you have your smallest angle across smallest side, middle to middle, large to large. All right, our third and final example that we're going to do completely together is what happens when we have a triangle with three sides and we want to know the missing angles. So once again, we're going to use the law of cosines, but this time you have to be careful. Always start with, when you have three sides, so always start with the largest side. And so the largest side is 10, so that'll be by itself. 10 squared equals 5 squared plus 6 squared minus 2 times 5 times 6 cosine of z. Now in this case, we're solving for an angle. So 100 equals 25 plus 36 minus 60. So that's 2 times 5 times 6. This is 61, so we get 100 equals 61 minus 60 cosine z. Now I want you to be careful. You cannot combine these terms. So I need to subtract 61 from both sides to get 39 equals negative 60 cosine of z. To get rid of the negative 60, we divide both sides by negative 60. So 39 divided by negative 60 gives me negative 0.65 equals cosine z. Now we just do the inverse cosine, and yes, keep it negative. And that gives you 130.5 degrees for z. Now, of course, you could just do the law of sines to figure out the rest. So we got sine 130.5 over 10 equals sine x over 5. Cross multiply. 5 sine 130.5 equals 10 sine x. Go ahead now and you want to make sure you divide both sides by 10. So 5 sine 130 divided by 10 gives you sine x equals 0.383. And do the inverse sine of that. Of 0.383. And you get that x equals 22.5 degrees. And then just subtract from 180. So please make sure you practice your homework and set up your problems. Good luck and thanks for watching.